Hello everyone, in this video we will see examples to find the consistency of a system of linear equations. In that first example, test the consistency and solve the system of equations x plus 2y minus z is equals to 1, comma 3x plus 8y plus 2z is equals to 28 and 4x plus 9y minus z is equals to 14. So here, to test the consistency, first we need to check the given system is consistent or inconsistent. Suppose if it is consistent, then we need to find out the solution of the equations. Therefore, in the solution, by using these three equations, first we need to write in matrix form. So matrix form should be in the form of what? Ax is equals to b. First write matrix of a coefficient value. That is x coefficient, that is 1, y coefficient, that is 2, and z coefficient minus 1 in first equation. And in the second equation, 3. Next is y coefficient 8, z coefficient is 2. In the third equation, x coefficient 4, y coefficient 9 and z coefficient is minus 1. So this is matrix of coefficient values. Next, after that, next we need to write a matrix of unknown values. Unknown value is x, y, z is equals to. Next, write matrix of constant values. What is the constant value in equation number 1? 1. In equation number 2, 28, and in equation number 3, 40. So this is the matrix form. Now write augmented matrix. So that is denoted by this symbol, transfers to. So write, that is 1, 2, minus 1, second row 3, 8, 2, next 4, 9, minus 1, followed by the colon. Then write the constant matrix value 1, 28, 40. So this is augmented matrix. Now we should apply row reduced to echelon form to find rank of augmented matrix. Therefore, so apply row transformation. So first we need to make these two elements 0. Already first row, first element is already 1. So next step is what? Second row, first element, third row, first element, we need to make it 0. Therefore, apply the row transformation. We are changing R2, therefore R2 changes to R2 minus 3 times of R1. Next, R3 changes to R3 minus 4 times of R1. So that time these two values directly goes to 0. Now we are changing R2 as well as R3, therefore write R1 as it is. Therefore 1, 2, minus 1, 1. Next, so use the calculator, no problem. R2 is 3 minus 3 times of R1 is 1. So 3 minus 3 times of 1. So directly 0. Next, R2 8 minus 3 times of R1 is 2. 3 times of R1 is 2. 2. So write 2. Next, 2 minus 3 times of minus 1. Minus 1. 5. 5. Next 28 minus 3 times of 1, 25. Next similarly change R3. First R3 is 4 minus 4 times of R1 is 1. 4 minus 4 times of 1, so 0. Next R3 9 minus 4 times of 2, 1. Next minus 1 minus 4 times of minus 1, 3. And next 14 minus 4 times of 1, 10. Okay. Next now third row, this is second element, third row second element, we make it 0. For that again apply row transformation. R3 changes to 2 times of R3 minus R2, because R2 value is here 2, here 1 is there, so to make this 0 we need to apply 2 times of R3 minus of R2. Again same thing, so here directly goes to 0. You can check 2 into 0 minus 0, so it is 0. So that time remember R1 and R2 keep it as it is, 1 2 minus 1 1. Second row 0 2 5 25. Now this value is 0. Next 2 times of R3, R3 is 1 1 minus R2 is 2, so that time it is 0, so 0. Next 2 times of 3, 2 times of 3 minus R2 is 5, 1, it is 1. So next 2 times of 10 minus R2 is 25, so directly this value goes to minus 5, minus 5. Now we reduced in echelon form. So now here total 3 non-zero rows are there, therefore write rank of augmented matrix. This is augmented matrix. Is 3, because 3 non-zero rows are available. Next rank of A, so this is A matrix, correct? Therefore rank of A is also 3. Therefore what we observed here, rank of augmented matrix is equals to rank of A, correct? Rank of A, rank of augmented matrix is equals to rank of A. Therefore the given system of equation is consistent. Therefore write given system of equation is consistent. Now rank of augmented matrix is 3, rank of A is also 3, and n is also 3. This n indicates the number of unknowns. Here total 3 unknowns are there, x, y, z. Therefore n value directly goes to 3. Therefore rank of augmented matrix is equals to rank of A is equals to n. So all 3 are 3. Then the given system has unique solutions. then given system has unique solutions. Now, to get unique solution, first this augmented matrix we need to write in equation form. Therefore, this first row can be written as 1, 2, minus 1. 1 can be written as x plus 2y minus z is equals to 1. Now this second row can be written as 0 is there, so leave that x value. 2y plus 5z is equals to 25. So right here 2y plus 5z is equals to 25, and the last row, what is that last row? 1 colon minus 5. So x value don't write, y value also don't write directly, 1 means z. Therefore right here z is equals to minus 5. So now call this 1, call this 2, and call this equation number 3. We got z value how much here? Minus 5. Using this z value, next we need to find y. Therefore in the next step put z is equals to minus 5 in equation number 2. What is that equation number 2? 2y plus 5z is equals to 25. So z value substitute minus 5. So 2y plus 5 into minus 5 is equals to 25. So 2y plus into minus is minus 5 into 5, 25 is equals to 25. Therefore 2y is equals to this 25, keep it as it is, shift this minus 25 to right hand side. So that time minus 25 becomes plus 25. Therefore 2y is equals to 50, y is equals to 50 divided by 2, cancel these two. So what is the y value? 25. Next, after getting y 25, in the next step what we need to do is this z value and this y value substitute in equation number 1 to get which value? X. Therefore write, put z is equals to minus 5, y is equals to 25 in 1. So what is that equation number 1? X plus 2y minus z is equals to 1. Therefore x plus 2 into y is 25 minus z is minus 5 is equals to 1. Therefore x plus 2 into 25, 50, minus into minus plus 5 is equals to 1. Therefore x plus 50 plus 5 is 55 is equals to 1. Therefore x is equals to 1 minus 55. Shift. Plus 55 becomes minus 55. Therefore x is equals to minus 54. 1 minus 55 is minus 54. So this is the solution. Next example, test the consistency and solve x minus 4y plus 7z is equals to 14, 3x plus 8y minus 2z is equals to 13, and 7x minus 8y plus 26z is equals to 5. To test the consistency, first as usual we need to check the given system is consistent or inconsistent. Suppose if it is consistent, we need to find the solutions of the equations. Therefore in the first step we need to write these three equations in matrix form. Ax is equals to b. So first write matrix of coefficient values. What is the x coefficient? 1, y coefficient minus 4, z coefficient 7. Again in equation number 2, 3, 8 minus 2. 3, 8 minus 2. Equation number 3, 7 minus 8, 26. Next, write matrix of unknown values. What is the unknown value here? X, Y, Z. Next is equals to, next write in the right hand side a matrix of constant values. What is the constant value? 14, 13, next is 5. Next write augmented matrix. So this is the symbol transfers to. So 1 minus 4, 7, 14. Second one, 3, 8 minus 2, 13. Next 7 minus 8, 26 colon. Next is 5. So this is augmented matrix. Now we should apply row reduced to echelon form to find out rank of this augmented matrix. Now leading element is 1. Next what we need to do? Second row first element, third row this first element we should make it 0. For that apply row transformation. So which row transformation we are going to apply here? R2 changes to, so R2 is 3, therefore we have to minus 3 times of R1. Similarly R3 changes to R3 minus R3 is 7, so multiply here 7 times of what? R1. So that time we are not changing the first row, therefore first row keep it as it is. 1 minus 4, 7, 14. Now R2 is 3, so it is 3 minus 3 times of R1 is 1, so directly 0. Next R2 8 minus 3 times of minus 4, 20. Next minus 2 minus 3 times of 7, minus 23. Next 13 minus 3 times of 14, minus 29. Next R3 is 7 minus 7 times of R1 is 1, 7 times of 1, so it is 0. Next R3 minus 8 minus 7 times of minus 4, 20. Next R3 26 minus 7 times of 7, 7 times of 7, minus 23. Next 5, that is R3 minus 7 times of R1 is 14, so this is minus 93. Next third row, this is second element, we have to make it 0, therefore apply the row transformation. R3 changes to, so this is R3 minus R2, so 20 minus 20 directly goes to 0. That time write first row and second row as it is, because we are changing R3. 1 minus 4, 7, next 14, second 0, 20 minus 23 minus 29. Next R3 minus R2, 0 minus 0, 0. Next R3 20 minus 20, again 0. Next minus 23 minus of minus 23, that is 0, correct? Minus 23 minus in bracket minus 23. So this is 0. Next R3 minus 93 minus of minus 29. So this is minus 64. Minus 64. Now we reduced the given augmented matrix in echelon form. Therefore, this is the augmented matrix. So here 3 non-zero rows are there. Therefore, rank of augmented matrix is 3. Next, rank of A matrix. What is that A matrix? This part is the A matrix, but we can observe here only 2 non-zero rows are available. Therefore, rank of this matrix goes to 2. So what we are observing, rank of augmented matrix we are getting 3 and rank of A matrix we are getting 2. So in the previous part we know this rank of augmented matrix is not equals to rank of A, then given system of equation is inconsistent. If it is inconsistent, it means the system has no solution. Therefore, we have to write here, therefore rank of augmented matrix is not equals to rank of A. Therefore, the given system has, therefore the given system has inconsistent. Inconsistent, it means system has no solutions.